Hello my dear students, today's topic is preparation of aldehydes and ketones. Please do remain till the end. Lots of tricks, techniques are fusioned here, okay? So let's start, try to understand. Primary alcohol such as methyl alcohol, ethyl alcohol, matlab alcohol contains CH2OH group. If any alcohol contains CH2OH group, that's called primary alcohol. Small amount of primary alcohol, say methyl alcohol, ethyl alcohol, is taken in this beaker. Just add a little bit potassium dichromate or potassium permanganate, should be acidified in nature or alkaline. What will happen? In organic chemistry, potassium permanganate and potassium dichromate are very useful oxidizing agents. They are strong oxidizing agent. So they oxidize primary alcohol to aldehyde. The aldehyde so formed readily undergoes further oxidation. To form carboxylic acid. So what you learned in chemistry, potassium dichromate or potassium permanganate acts as strong oxidizing agent. Any primary alcoholic compound containing CH2OH group called primary alcohol, such as methanol, ethanol, etc. When any one is added to any primary alcohol, it at first oxidizes to aldehyde. The aldehyde so formed further undergoes oxidation. Under the reacting condition, you no need to add anything. Readily change into carboxylic acid. So primary alcohol directly will change into carboxylic acid, though you know that aldehyde is intermediate. The aldehyde you can't get it, though you know that aldehyde is intermediate. So if we want to stop the further oxidation, of aldehyde to acid, we can't use this type of strong oxidizing agent. Rather use mild oxidizing agent. In this case, mild oxidizing agent, and you will get aldehyde. The oxidizing agent, mild oxidizing agent, cannot change the aldehyde to acid. This type of oxidation is called controlled oxidation. So by complete oxidation, primary alcohol finally gives carboxylic acid, but under controlled oxidation, primary alcohol undergoes aldehyde. The controlled oxidation or partial oxidation can be carried out in presence of mild oxidizing agent. What type of oxidizing agents are used here? Let's proceed. Primary alcohol on partial oxidation in presence of weak oxidizing agent gives aldehyde. Secondary alcohol on oxidation gives ketone. In this case, you need not add any mild oxidizing agent. The mild oxidizing agent can be used, but other oxidizing agents such as potassium permanganate, potassium dichromate can also be used, because ketone does not undergo further oxidation, but aldehyde undergoes oxidation to carboxylic acid. That's why. Now question is that what type of oxidizing agents are used here? Remember it, under normal condition ketones do not undergo oxidation, but under drastic conditions, by applying special conditions and in presence of very strong oxidizing agent, ketone undergoes oxidation. In chemical properties I will discuss that. Only remember it that primary alcohol on partial oxidation or controlled oxidation gives aldehyde, secondary alcohol gives ketone. Now question is that what type of oxidizing agents are used here? Listen. When primary alcohol undergoes controlled oxidation in presence of These are the weak oxidizing agent, Collins reagent and pyridinium chlorochromate. So what you learn, any primary alcohol, whether methyl alcohol, ethyl alcohol, propyl alcohol, butyl alcohol, when undergoes controlled oxidation in presence of Collins reagent and PCC, pyridinium chlorochromate, we get aldehyde. How to remember it? CH2OH group will change into CHO group. This is aldehyde group. So what are Collins reagent and what are PCC? How to remember it? Follow the technique. Collins reagent is a mixture of 1 mole of chromic oxide and 2 molecules of pyridine. Pyridine is a base. 1 molecule of chromic oxide and 2 molecules of pyridine. And PCC, PCC is, just write it, instead of 2 molecules of pyridine, take only 1 molecule of pyridine. And instead of other molecule of pyridine which I have only not written, take HCl. This is called PCC. They are used as weak oxidizing agent in chemistry. So I think you clear. Now let's give 1 or 2 examples, okay? When methanol undergoes oxidation in presence of PCC, you get methanol. How to remember? Follow the technique. You can write methanol in this manner. Indicates that it has primary alcoholic group and directly change the primary alcoholic group into aldehyde. That's the technique. So how to learn it? CH2OH group I have already mentioned. Change into this instead of PCC or Collins reagent. It is ethanol or ethyl alcohol. You can use PCC or Collins reagent, okay? Just change the primary alcoholic group without changing the methyl, ethyl or any group. So you get ethanol or acetaldehyde. This is the technique, okay. Now the second method of preparation, that is ozonolysis. It is very important for your board as well as entrance exam. Clear? Now let's start ozonolysis. So listen, ozonolysis reaction takes place in case of alkenes, that is compounds containing carbon-carbon double bonds, as well as alkynes, that is compounds containing carbon-carbon triple bond. Take any alkenes, say ethene CH2 double bond CH2, add ozone, small amount of ozone. Alkene is reactant, ozone is reagent. Ozone acts as oxidizing agent in chemistry, remember it. Now when you add ozone, we get one intermediate product called ozonite, that is unstable, short-lived. Now further, after some times, add zinc and little bit of water. Zinc being metal acts as reducing agent. Zinc being metal acts as reducing agent, and you get aldehydes or ketones or both, depending on the nature of alkenes used. You can use alkynes also, okay. You can use alkynes also during ozonolysis reaction. There are two types of ozonolysis reaction important for entrance. One is reductive ozonolysis, that is in our syllabus in class 12. Another is oxidative ozonolysis, that is for entrance. So I will discuss the both, okay, because this is the fusion of board as well as entrance. So write down. when alkenes or alkynes, compounds containing carbon-carbon double bond are alkenes and compounds containing carbon-carbon triple bonds are alkynes, react with ozone, we get unstable intermediate called ozonide. Now two options. When ozonide is heated with a mixture of zinc and water, we get aldehydes or ketones or sometimes both, depending on the nature of alkenes or alkynes used. Another reaction, that's for entrance, when ozonide is heated with zinc and acetic acid. Instead of water, use acetic acid. You get carboxylic acid, means the aldehyde further undergoes oxidation to carboxylic acid. So this is reductive ozonolysis, this is oxidative ozonolysis. Remember it. This type of ozonolysis is called reductive ozonolysis. This type of ozonolysis is called oxidative ozonolysis. This is very important for entrance. In my entrance class, I will discuss this, okay? Now here I will discuss only this. So, learn the technique, how to write the products of ozonolysis. When ethene reacts with ozone, then one unstable intermediate ozonide is formed. How to draw the structure? Technique. Just remove the double bond. Remember it, ozonolysis takes place at the side of double bond. Write this way, like a home. When it is heated with, when ozonide is heated with a mixture of zinc and water, then you know that this is called reductive ozonolysis. It is in your syllabus in class 12, and oxidative ozonolysis in entrance. Again technique. Just remove the oxygen. Attach this oxygen with water. So you get hydrogen peroxide as the byproduct. Now, mention the electrons of this bond. Now, break the bond. You know that any bond contains 2 electrons. single bond is already there. Incoming of this 2 electron makes another bond. So you get formaldehyde. Just combine the hydrogen, you will get this type of structure, okay? In formaldehyde, just combine the hydrogen with carbon, you get this. This is up to the board exam. But if you want to learn for entrance, follow the tricks. Because in entrance, time management is the main thing, okay? This is for entrance, okay? If question will come in this way, how to write the structure directly, the product? Just break it. Insert one oxygen here and one oxygen here, okay? You get the product. Carbon possesses tetravalency, that's why 2, 2, 4. This is the technique. Now the next example of reductive ozonolysis reaction. This is propene, methane, ethane, propane, in, propene. Just break the double bond because ozonolysis takes place at the site of double bond only. Insert one oxygen here, one oxygen here. As the compound, that is propene, contains only one double bond, so you get only one molecule of hydrogen peroxide as the byproduct. Remember it for entrance exam. If any compound contains two double bonds, then due to ozonolysis you get two molecules of hydrogen peroxide. If any compound contains three double bonds, you will get 3 molecules of hydrogen peroxide. So, if any question in entrance will give in this aspect that, say during ozonolysis reaction, 3 molecules of hydrogen peroxide are formed as byproduct, how many numbers of double bonds are there in the parent alkene? Option. Answer is same. 3 molecules of hydrogen peroxide are formed. So the alkene contains 3 double bonds. Understand? Next. another example, but you will do at home. These are to your homework, okay? Follow the technique, but I don't write any answer. Break it, insert one oxygen here, you get the product. Break here, insert one oxygen here, you get the product, okay? Now the next preparation, write it. Third preparation. By Rosenmann reduction. Listen, what is this? Follow the technique at first, okay? Then I will write the detail. This is acyl chloride group, COCl. Acyl chloride group, any compound, whether aliphatic or aromatic, when hydrogen gas is passed through it in presence of palladium and barium sulphate, you get aldehydes. Reducing agent, any metal, so it's a reduction. That's why it is called Rosenmann reduction, because here palladium acts as reducing agent. How to write it? So write it. So let's check the examples, okay? Just follow the technique. So you see that during Rosenmann reduction, just change the Cl group of acyl chloride into hydrogen. You get the required aldehyde. This is the technique. This is the technique. Remember it. Chemistry stands on technique. Examples. Can you write the product? Just follow the technique. Just follow the technique without remember anything, any reaction. If benzene contains CO group, that's called benzoyl, Benzoyl. So it is benzoyl chloride. So you get benzaldehyde. These are the examples of Rosenmann reduction. You can apply the reduction in any aliphatic or aromatic compound containing COCl group, that is acyl chloride group. Remember it. What is the technique? Just change the Cl atom of acyl chloride group into hydrogen. You get the product. Now question may come to our mind, sir, palladium acts as reducing agent here. Okay, I understand. But what is the function of barium sulphate here? This is the very important question for board and entrance. Listen. What is the function of barium sulphate in Rosenmann reduction? Sometimes I have seen in some books, along with barium sulphate, a small amount of quinoline are used. Quinoline are basic in nature, okay? That will try to understand. After that, I will write the answer, okay? Understand it. You know that during Rosenmann reduction, acid chloride will change into aldehyde, that you know. Acid chloride will change into aldehyde, that you know. But remember it, aldehyde can undergo further reduction to give primary alcohol under the reductive condition. But our target is not to get primary alcohol but to get aldehyde. That's why barium sulphate poisons the catalytic activity of palladium so that further reaction cannot occur. Listen, you get aldehyde here. If you do not use barium sulphate, then what happens? The reaction proceeds, aldehyde you get as intermediate, but that aldehyde so form undergo further reduction to change into primary alcohol. But our target is to get only aldehyde, not alcohol. So we have to stop the further reduction, that is, we have to reduce the catalytic activity of palladium. That's why if you use barium sulphate, it poisons the catalytic activity of palladium for further reduction. So further reduction of aldehyde to alcohol cannot occur. This is the function. I think you understand it. So what is the answer? If you want to write in your board exam, this is a very important exam question. Listen, barium sulphate poisons the catalytic activity of palladium for further reduction of aldehyde to alcohol. That's much. So I will write it. I think you understand it, okay? Now the next preparation, that is preparation 4 by Stiffen reduction. Very important. During Stiffen reduction, one intermediate is formed called imine, I-M-I-N-E, imine. It's a type of functional group in organic chemistry. And intermediate imine is the entrance question. Clear? So let's start Stiffen reduction.